All right. So once again, my name is Rosie Cook. I am the Assistant Curator and Registrar at the Chemical Heritage Foundation here in Philadelphia. And I'm going to talk to you a little bit more about the personal side of instruments. I've prefaced most of my talks with, I am not a chemist. I got a D in chemistry because the teacher was really nice to me. He was also my friend's father, so that might have had something to do with it. But when I first started at the Chemical Heritage Foundation, I was extremely interested in learning the stories behind these, what we call black boxes. I walked into a storage room full of black boxes, knowing absolutely nothing about them. Luckily, Chemical Heritage Foundation has great scholars like David. We also have a really great group of retired chemists and chemical engineers, one of whom is in the audience. And it's through these people that I not only learned about what the instruments themselves do, but also this really great backstories about the instruments. So the premise that I sort of started with when thinking about this talk is the difference between people and their discoveries. So the question here is, do the people behind the science really matter? Three people you'll see here. The first gentleman is Carl Skip Marvel, who is mostly a textile chemist. The gentleman in the middle is Dr. Alan McDarmid, and the gentleman on the far side is A.O. Neer, who is a mass spectrometrist. Or is it really only their discoveries that as historians of science and people that we're really interested in? So these are the three sort of big things that those people are known for. Dr. Marvel discovered something called PBI. It stands for polybenzimidazole. Today it's most commonly used in firefighter coats. That's why they have that really great lining color. Dr. McDarmid was doing research in organic metallic conducting polymers, which as a non-scientist, I kind of go, what? How can a polymer be metallic? So sort of interesting along those lines. And then A.O. Neer, as I said, was a mass spectrometrist. This is his 180-degree flight tube out of one of his mass spec machines. Dr. Neer did a lot of work on isotope analysis. So then I started pondering this quote. This quote is actually up in our collection storage room. It says, "What would you attempt if you knew you could not fail?" And I think this is pretty much sort of a guiding principle for a lot of people who go out on their own, or at least that I've spoken to at the Chemical Heritage Foundation, when I ask them, why in the world did you decide to do X or Y? A lot of people's response is, well, I thought it'd be fun. Or more importantly, I saw a problem and I didn't know how to fix it, or there wasn't a tool out there to fix it, so I just decided to create my own. And that takes an enormous amount of guts to do. Both Davis and David both talked about individuals who sort of saw potential and went forward, a lot of times at great personal risk. Dr. Beckman very easily could have bankrupted his company by trying to go into digital computing, but didn't. So I'm going to talk to you about three people, three case studies that we have at Chemical Heritage Foundation who sort of embody this, what would you do if you didn't think you could fail? So the first person we see here, this is Dr. Paul LaRue Burr. Dr. LaRue Burr was a specialist in NMR. This is his instrument that he used. This is an A60 NMR spectrometer. Yes, it is missing its magnet. This is not Dr. LaRue Burr's NMR. This is actually an NMR that you'll see on display at CHF that came to us from Stanford University, but it is of the same generation. I never had the fortunate chance to meet Dr. LaRue Burr before he passed away, but I did have a chance to meet his wife, Joan Dawson, who was also his research assistant. She was at Chemical Heritage Foundation as a scholar and as a researcher, helping us sort through his stacks and stacks and stacks and stacks of papers. If you have ever had the chance to meet a Nobel laureate, you will learn that one of their common traits is they never throw anything away. But I also had the fortunate chance to go out to Dr. LaRue Burr's house to help pack up some of the ancillary materials. And so we got to see his laboratory, we got to see his house. And by talking to Dr. Dawson, we had the ability to really get to know the individual. The story behind Dr. LaRue Burr's discoveries are very well known. He was a chemist. He was trained at Stony Brook in New York. And he is one of the first people to use the concept of NMR technology into MRI technology. One of the things I did learn, and this is repeated over and over and over again, is if you are a scientist, write down your ideas and get them notarized. Dr. Dawson said one of the things he always sort of regretted is that he never got his notebooks notarized. So when it came to patent applications and things like that, he sort of lost out. But there's this great story about the first living organism that Dr. LaRue Burr sent through his MRI. Most people know these are these tiny little clams that he wrote about in his first publication. And while the clams have long since disappeared, the photographs, obviously, the films still exist. But we were busy packing up his medals and his memorabilia in his office, and Dr. Dawson walks up to me and she says, "Well, you're the object person, so I'm going to ask you, do you want this?" And in her hand is a coconut. And I said, "Well, I like coconut, but something tells me there's a bigger story behind this, so what is it?" She said, "This is actually the second thing that Dr. LaRue Burr sent through the MRI machine that he had created." And she said, "And nobody wants it because it's the second." And I said, "Well, absolutely I want it." My coworkers will tell you that my response was a little more jumping up and down and being very excited. But what that coconut in our collection allows us to do is to say, okay, yes, these little tiny clams are gone. In fact, they'd probably smell really bad by now. But this coconut, which is sort of this nice self-contained kind of thing, it may not be the first, but you know what? The second tells just the same kind of story. So when we have tours, when we have the ability to talk to people, we bring out the coconut. If you come to CHF, you'll see the NMR that's up on display, along with a conversation about the tiny clams. You will also see Dr. LaRue Burr's notebook. You'll also see his Nobel Prize. And you'll see a modern MRI film. And occasionally we do bring out the coconut for effect. And people are really, really interested because, again, it's this story of individuals who took a chance and he said, well, okay, I can do clams, now what else can I do? And he just, I don't know why, he happened to have this coconut laying around his office and decided to send it through. And now we have it. And it's this ability to tell this completed story. And as Dr. Dawson said, Dr. LaRue Burr was a little bit of a different kind of guy, so he sent all sorts of different things through the machine. Second person I'm going to talk about, this is John Fenn, who is a favorite of mine. I like Dr. Fenn. I refer to him as the rock star of the mass spec world. He recently passed away. I had the privilege of meeting Dr. Fenn for the first time probably 5 or 6 years ago, actually at a Pittcon conference in Chicago. And the instrument that you'll see, this is actually a shot of the instrument in the museum. This is his ESI, which is stands for Electrospray Ionization Mass Spectrometer. There are instrumentation racks that go with it. They're in storage. They're not nearly as interesting as the actual instrument itself to our visitors. And I also had the privilege of going to Connecticut to do a video oral history with Dr. Fenn. Our video oral histories at CHF differ from a typical oral history in the sense that our videos are really only interested in capturing the information about the object. How does the object work? What did you do with it? How did you come up with the idea? Literally plug it in and show us how it works. And in his case, he could actually plug it in at this point. And we must have spent 5 or 6 hours at his company, just listening to him talk about this instrument, learning so much about these really great antiquated stories of when he was building this instrument. My favorite being that they were running an analysis and they were getting strange peaks on their outputs, and they could not figure out what it was. So they shut the whole thing down. They had to check all the tubes. They checked everything. They still couldn't find it. So they ran a test again. And finally, one of his students looked at him and said, "Dr. Fenn, we're getting a weird peak at caffeine. It seems to be the thing that we're picking up." Turns out a professor down the hall was brewing an extraordinarily strong pot of coffee. And for some reason, the molecules that were in the air were being picked up by the ESI. So then they had to tear all the tubes out and redo the whole vacuum system, because obviously there was a leak. ASMS was here in Philadelphia probably 4 years ago, I would think. And we had a joke at CHF that we were going to charge $5 to pat the Fenn, and we could have all retired at that point. But Dr. Fenn had never seen the instrument installed in our museum, so I invited him down, and we just happened to have a school group in the museum at that point. And our head tour guide was giving a tour, and she had said to the students, they were upstairs and we were downstairs on the main floor, and she had said, "Remember we talked about Dr. Fenn?" And they were, yeah, that's Dr. Fenn. And these are high school students. They're AP chemistry students, so most of them are either juniors or seniors in high school, and they were blown away. And their teacher had asked, "Well, do you think we could take a picture? It's not every day that students get to meet a Nobel laureate." And so she comes down, she asks me, and I asked Dr. Fenn, and he said, "Oh, sure, tell him come on down." 45 minutes later, he was still talking to them about how you should follow your dreams, about how he didn't start this research until the late 1980s. And even then, people told him that he was completely foolish and that it would never happen and it would never work. And he left them with what I think is probably the best kind of antecedent from I've been at CHF for almost 10 years. And he told them, he's like, "You can never stop dreaming, because you never know, one of you may be the person to come up with the idea that's going to solve AIDS or cancer or an electronics problem or something like that. You never know until you try." And that's the message that he left with them. And I asked him later, I said, "Dr. Fenn, it was really nice of you to spend that much time with those students." And he said, "That's what I love to do." He said, "Besides crawling inside instruments and trying to fix them, I love inspiring people." And the third person I'm going to talk about is Jenny Gutzler. Unlike the other two individuals, she has not won a Nobel Prize, not yet. And she's not a very commonly known individual unless you happen to work here in the city of Philadelphia and you happen to work at Fox Chase Cancer Center. Jenny Gutzler is an X-Ray crystallographer at the Fox Chase Cancer Center. Her main area of research is protein analysis. And she taught me so much about X-ray crystallography that it's crazy in 5 hours of doing yet another video oral history with Jenny. This is her instrument that we took from her lab. It's a fairly older version of the X-ray crystallography camera and X-ray source. Jenny has a really interesting sort of background. She is English. She studied with Dorothy Hodgkin in London. And then when she got married, she actually transferred, she and her husband moved to California because her husband, who was also a chemist at that point, was going to do a postdoc under Linus Pauling at Caltech. And she was actually one of Linus Pauling's first female graduate students at Caltech. She is very tenacious and was very forceful and didn't understand why Caltech at that point did not allow female graduate students. and basically wrote to Dr. Hodgkins and got Dr. Hodgkins to sort of advocate on her behalf, so she was admitted into the university. She was also a student of Lindo Patterson's, so she has a really great sort of academic history behind her when it comes to X-ray crystallography. But again, one of the best stories that she told me involves this lady down here who some of you may know, that's Rosalind Franklin. She said she was a student in London and got sent to an X-ray crystallography conference in Paris. First of all, as a graduate student, I would love to have gone to a graduate student conference in Paris. They didn't offer them in my field, unfortunately. And so she's sitting in a large lecture hall, I'm assuming similar to this, and she's sitting next to this woman who she doesn't know, and the lecture is really, really boring. And the woman next to her leans over and says, "This is bloody boring. Do you want to get out of here?" She has no clue who she is, but she's bored, and she's about 20 years old. She says, "Absolutely." So she goes out with this woman. They go for tea, and the woman introduces herself, and she says, "Hi, my name's Dr. Franklin." And so, of course, Jenny at this point had heard of her, and was totally confounded that this really famous woman would take interest in a student. They ended up spending the entire day together. They went to a fashion show because it was during Paris Fashion Week. And as she said to me, I learned more about X-ray crystallography and how to be a scientist from that afternoon spent one-on-one with Dr. Franklin than I ever learned in an actual laboratory or a classroom. So it's these three stories that sort of take me back to that first question that we had. Oh, I'm just going to back up a little bit. Is this, do the people behind the science matter? And I think in the realm of the work that I do at the Chemical Heritage Foundation, which is where we like to talk about not just the science, but we talk about the people behind it and the history behind it. I think in that essence, it is the people that matter. It is the people who make innovation happen. And a lot of times it seems, especially in modern days, that the people are getting lost. You saw some of the patents that, again, that Davis and David had put up, and now if you look at patents, there are 7, 8, 9, 10 names on a patent. And it's really hard to sort of understand what all of those people do. And that's where people like David and Davis and what we do at the Chemical Heritage Foundation, I think is really, really important, is that the science is very important because, of course, it makes our lives better. But understanding the motivations and the people who are actually doing it is also very important. Innovation doesn't just happen. Spontaneous discovery doesn't just happen. Things don't just happen on their own. Instruments and experiments don't happen on their own. A lot of times it's the lowly graduate assistant or the intern or someone real low on the R&D circuit who kind of comes up with this idea and sort of pushes it through and really believes it. And I could stand up here for hours and tell you stories out of CHF of individuals who believed in a product, pushed for a product, drove a product around, drove a product to the very first Pittcon in the back of their station wagon, got into fistfights with salespeople on the sides of the road because the salespeople just weren't selling the instrument the right way. I could tell you hours and hours and hours of stories. But I think that when we start thinking about innovation and we start thinking about instrumentation, we think about science, that it's really important that we don't lose track of the individuals who are doing it and the people, and so that it's about the people and not just about the products.